background. This is homework 5 implementation in Python for Hyperparameters. So in a Python notebook, I implemented each of the hyperparameter experiment listed in the assignment as a separate row, as you can see here. And if I click run, everything is running, and the output of each hyperparameter experiment will be pretty much the same as it was described in the assignment here. So in order to achieve that, I had to modify the Python file where I added certain classes to calculate log likelihood cost, ReLU, sigmoid, softmax, and ton functions. Also, I had to modify the feedforward part where I check for the layer number. So basically, if it is the last layer of the network, then I treat it as an output layer. And if it is not, then I treat it as a hidden layer. The same happens for the backprop function, where I check for the index of a layer again. And if it is the last layer, I cast it as a output layer. Also, for the biggest changes were for regularization, particularly for L1 and L2. So for L1, I had to modify mini-batch function where I check for a regularization type. If it is not provided, then I just return the weights as it is without any changes, and biases won't be affected at all. So if it is L1, then I had to modify the code a little bit when I added sign function, and also according to the formula that's listed here. So it wasn't a lot of modifications there. Besides that, I had to change the total cost calculation where I check for the type of regularization again. And if it is L1, then I had to modify, a linear norm function parameter where I add 1 if it is L1. And basically that means that I will calculate the sum of the absolute value. Basically, will be max sum of the absolute value here. And if it is not provided, then it will be like the L2 regularization here. Also, if it will be L1, then nothing will be here and in front. And if it's L2, then it will be divided by 2. Also, if it is L1, then there's no the power will be 1, and if it is L2, then we square it. Also, for the sum of modification I had to do for the to implement a dropout regularization, particularly I had to modify mini-batch function where I check if I apply the same mask every time to the backprop in one mini-batch. So I initialize mask here, and I basically go to the backprop function where I check if the masks were initialized. So here it will create a mask for each of the hidden layer, and then it will use this mask further for this mini batch. So it will return basically an array of masks for each layer here as a parameter. And the way how I calculate the mask is basically described in a dropout function where I calculate basically binomial distribution of the of the layer of the nodes of the layer, and I calculate the probability is 1 minus dropout percent of it. That's so I implemented this dropout function, but it seems like something might not work as I expected, because the output of this particular dropout function was a little bit different than it was for the output that was described in the homework assignment. So I think I described pretty much everything here, so thank you for the listening.